Hello guys, in this video I am going to explain the solution of this question number 40 of chapter 13 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. The question says that we need to determine this I2 and V2, this current and this voltage for the ideal transformer circuit that is shown in this, and if there are three cases A, B and C, and in the first case V1 and ZL is given and we need to determine the I2 and V2. And over here in this question, from this question we can determine that the turn ratio, this A, it is equals to 6. Right now, if we try to solve the first part of the question, now in the first part it is given that V1 is 4 angle 32 degree volt and ZL it is equals to 1 minus j omega, which is equals to root 2 angle minus 45 degree. Right now there are two ways to solve this type of a question. One is that we can determine Zn. If we determine Zn, then the formula for Zn, it is ZL upon A square. Now ZL is our root 2 angle minus 45 and A is 6. This is 6, right? So it is divided by 6 square. So it is root 2 upon 36 angle minus 45 degree, and since it is Zn, so the unit will be ohms, right? Unit will be ohms. Let me put a yes. Now once we get a Zn, we know that what is the purpose of Zn? Zn is the input impedance that we are able to see from this. So the impedance of this part, it is given by Zn. Means once we determine Zn, then our circuit, we can redraw this circuit like this. This is V1 plus minus, this is I1 and this is our Zn, right? It means that if I want to determine the I1, then I1 will be calculated as V1 upon Zn. V1 it is given that V1 is this, so it is 4 angle 32 upon Zn. Zn is this, so it is root 2 upon 36 angle minus 45. So solving this 36 will come up, so this I1 we will get it as 72 root 2 angle will be 32, this 32 minus, let me write it as 75. So solving this we will get 72, this is complete angle 77 degree, and the unit, it will be simply ampere, because this is in ohms, and the volt is in V. So our I1, it is 72 root 2 angle is 77 degree amperes. Right now, once we get I1, we have the formula, we have a formula that I2 upon I1 is equals to 1 upon 8. It means that I2 can be determined using I1 upon 8, right? So I1 is 72 root 2 of angle is 77, divide by A, so we will get 12 root 2 angle is 77, so ampere. So this is the first part that we need to determine. We need to determine the value of I2, which is 12 root 2 angle 77 amperes, right? Another thing that we need to determine, the voltage V2, right? So V2 can be determined like already we got I2. So if you look at the circuit, as per the circuit, this V2, it is equals to I2 into ZL, right? I2 into ZL. So this we can determine like V2 is equals to I2 into ZL. So I2 is 12 root 2 angle 77. And what is ZL? ZL is this. Not this. ZL is this one. It is root 2 angle minus 45. Angle minus 45. So now this 12 root 2 into 2, it will be 24, and this 77 minus 45. So it is 24, angle will be 32 degree. So this is our V2. Now this is one way in which we have first determined this Z input, and from Z input then we determine I1, and from I1 then we determine this I2, and once we get I2 then we determine V2. There is another short way, because we have another formula, and the another formula is that because we need to determine only V2 and I2, so we have one formula, and the formula is this, that V2 upon V1, it is equals to A, right? And since A is given, A is known, V1 is known, so simply we can determine V2 as A into V1, which is 6 into 4 angle 32, and so V2 it is 24 angle 32. Let me check if I got, you can see we get the same answer, right? So it is this. So this is V2. So simply we can determine using this formula. Now next is I2. Now since we already got now we got V2, we know ZL because ZL is given, and we got it like root 2 angle minus 45. So our I2 it will be V2 upon ZL. So using this formula, I2 equals to V2 upon ZL, we will get 24 angle 32, and ZL is root 2 upon minus 45. So solving this, we will get 12 root 2, I2 is equals to 12 root 2 angle 32 minus 45. So it is 12 root 2 angle 77 degree. So this is I2, and we can match it with the answer. You can see 12 root 2 angle 77. So over here I have shown both the methods. Means you can first determine the Z-in, and then you can determine I1, then I2, and then V2, or straight away you can calculate V2 and then I2. So any method, like you can use any method, and from both the methods you will get the same answer, right? Now, so this is the solution, this is the answer to the first part of the question. Now in the second case, it is given. Now for the second case I will use the simple method, the directly in which we calculated the V2. So in the second part it is given that V1 is equals to 4 under root 4 angle 32, and ZL is equals to 0 ohm. Now ZL equals to 0 ohm means that this is short circuited, and if it is short circuited, it means infinite current will be there, right? Infinite current will be there. So over here, if V1 is there, so I can calculate V2 as, we know V2 upon V1 is equals to A. So V2 will be equals to A V1. A is 6, V1 is 432. So it is 24 angle 32 degree volts. So it is V2. Right? Now I2. Now if I2 will be V2 upon ZL. Now ZL is 0. So it means V2 2 upon 0 we get infinite. So infinite current means practically it will damage the transformer, right? So in this way we can get the answer. Remember, if you follow the if you first determine Z in, and from Z in then you determine I uh, I1 and then I2. Now if you go in this way, then I2 you will get infinite, right? And once you get infinite, then if I2, if you first find I2 as infinite, then I2 into ZL. If you try to determine V2 equals to I2 into ZL, then you will get infinite into 0, and this is undefined, right? This is undefined. So in this case, you need to follow these steps. You need to, instead of calculating Z in, you need to follow this step to calculate the V2. And remember, because over here, even if if there is no element over here, then also the voltage will be there. Why? Because over here the voltage will be due to the mutual inductance, right, and the self inductance. So if the current is flowing in this coil I1, then this will induce the voltage in this coil due to mutual coupling, right? So voltage will always be there even if current is not there, right? So this is the solution to the second part of the question, that V2 is this and I2 is infinite. Now coming to the third part, and the third part says that, let me clean it a little bit. So the third part says that V1, this part, V1 is equals to 2 angle 118, and ZL it is 1.5 angle 10 degree. Now over here, following the simple method, V2 is equals to A into V1, so we will get 6 into 2 angle 118, so it is 12 angle 118 degree volts, right? Now I2 will be V2 upon ZL, so it is 12 angle 118 upon 1.5 10, so it